Hello. In this lesson, we're going to begin a new chapter. This chapter is all about what's called solving systems of equations. We'll learn what that is here in a little bit. But to start, just to get our brains going for the day, I'd like you to try these two warm-up questions, which are kind of going to act as semester test preview because we have our semester test coming up here soon. And a lot of the first semester involves solving equations, so we're going to review a little bit about what a good portion of first quarter involved, and that was solving equations, and we used the steps of simplify, same side, solve. So I'd like you to try these two questions. You can try it just on the margin of note packet, or you could try it on a scratch piece of paper or wherever you completed the last homework assignment. But I'd like us to pause the video now for maybe a minute and a half, should be plenty of time, and then unpause it once everyone's had a chance to try, and we'll come back and see how we did as we prepare for our semester test review. So pause the video now, please. Come back once you are ready. Okay, here we go. Simplify usually meant distribute or either combine like terms that are already on the same side. On the first one, distribution, you'd be distributing the -2. So you get -2x, negative times a negative, and make a +6 equals 16. Then you subtract 6 from both sides because you're done with simplify. Now you need to do same side. Get all your variables to one side, get your numbers to one side because you have variable, number, number. Your numbers are not on the same side yet, so get rid of your numbers. You then get -2x equals 10. Now have your variables on one side and numbers on one side, so you have same side. Last step is solve to divide by a negative. And then you get x equals -5 for your first answer. Second one. This one, the simplify step, is actually going to be combining like terms that are on the same side. So you have variable, number, number, variable, number. If you look, you have number terms that are on the same side. -10 plus 3 makes -7 equals 3x plus 13. Now you need to get your variables to one side, so maybe get rid of them on the right. Subtract 3x from each side, then 8x minus 3x is 5x, minus 7 equals 13. Now you have variable, number, number. You need to get your numbers all to the right, so add 7 to get rid of them on the left. You then have 5x equals 20. Divide by 5 and you get x equals 4. So that's what a large portion of first quarter entailed, was solving equations. And that's actually going to come up in this chapter. That's why it's a good not only semester test preview, but also a good review, as we'll need these tools later in this chapter. So now if you're following along in the notes, it'll say for the first section, it'll say solve linear equations by graphing. And here's a lead-in that kind of displays why we're going to be investigating what we are investigating, where this idea gets used in the real world. So here's kind of a simplified example. Let's say a pair of friends wants to start up a poster company. They estimate it's going to cost them $6,000 for initial materials. So that's like getting the building, buying all the printing materials such as ink and printers and copyright and all that stuff. And then $1,000 per month for regular expenses. So that would be paying to replenish the poster paper and the ink and things like that. What would their cost equation be? Well, it would look something like this. Y equals 1,000 for every month plus the $6,000 upfront fee. So Y is equal to dollars in the thousands. Don't want to carry around a bunch of zeros. And let's actually put the Y on this side. Makes more sense for points for X to be listed first. X is going to be number of months, and Y is equal to dollars in the thousands. However, the whole point of starting a business is not just to pay costs, because this is only the cost equation right here. It's to make money. We call that revenue. They estimate once they get going, they are going to earn $2,000 per month in revenue. What would the revenue equation be? Well, it'd be Y equals 2x. So Y equals 1x plus 6, Y equals 2x. This would be their revenue equation. Now, if you ever take a business class, one of the very first things they'll talk about is something called break even. Break even is when the cost is equal to the revenue. The cost equation is 1x plus 6, and the revenue equation is 2x. you could solve this algebraically, which is what we'll do later in the chapter, but you could also solve it graphically, which is what we're going to do here. So if I graph this cost equation, I start at 6, and that's my y-intercept, and my slope is up 1 over 1. Because the scales are the same, I can just count boxes. This is why it was so important that we studied how to graph lines in prior chapters. That's the cost equation. Here's their revenue equation. It's really 2x plus 0. Start at 0 because you don't make any money at the very first beginning. Go up 2 over 1, 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 and then you graph the line in. And we see that that is where they cross. That's the break-even point. At 6 months, they're going to break even. So it'd be at 6 months is when they break even. Before 6 months, their costs are higher than their revenue. After 6 months, their revenue is greater than their costs, so they should be making money. They would be what they would say in the business world is profitable. So one really big application of what we're going to do this chapter, finding where two lines cross, businesses call this the break-even point. Moving forward, we're going to kind of take away the context, and we're just going to be graphing lines and doing it mathematically. There's not going to be a story behind it, but you can understand maybe where this could get used. So our goal, the whole chapter, is one question: where do two lines cross? And so the most logical way to start would be, let's just graph the two lines. So if I had these two lines, they would say solve by graphing. What they mean is tell me where those two lines cross. So if I graph this one in red, I could graph by doing intercepts, put 0 in for x, find y, put 0 in for y, find x, or you can just solve for y by subtracting the x, and then you'd get 10 minus 1x. So I would start at 10, go down one, right one, down one, right one, down one, right one, and I just do this until I've plotted as many points as I can, because I don't know exactly which one of these is going to be where those two lines cross, and then I draw my line in. So that's what that line would look like. We're just showing the first quadrant here because this is going to cross in the first quadrant. Then I'll graph this other one. Y equals x plus 2. Start at 2, and the slope is 1, so go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And I can see then that they cross at the following point. You need to actually communicate where they cross, though. A point has two coordinates, so you need to list both of them. It's 4, 6 is the solution. How do I know it's a solution? How can I check my work? Well, I can put 4 in for x and 6 in for y in my equations and check. If I put 4 in for x and 6 in for y, I'll note 4 plus 6 makes 10. It works for the first one. If I put 4 in for x and 6 in for y, I note that 6 is equal to 4 plus 2. So it makes both of them true. This is the only point that's going to make both of them true. That's why that is the only solution. So when they say solve by graphing, they mean find where the two lines cross, find the pair, the ordered pair that would make both equations true. What we're doing is what the math community calls solving a system of linear equations, or simply a linear system. Why do they call it that? A system because it's more than one line, and linear because we're graphing lines. So that's what it means to be a system of linear equations. A solution to a system is the ordered pair. It's the point that makes both equations true. That is because that point is on both lines. It's the only point that will do that in most cases. So that's what we mean when we mean solve the system, is find the point, find the ordered pair that makes both equations true. That's because it is the only point that is on both lines. A system, one more time, of linear equations consists of two or more linear equations that have the same variables. X and y are the most common. Okay. To start, actually, what they might do is they might even give you a system that's graphed and just ask you to check the answer. So, for example, they've already graphed these two lines for us. Okay, and they just want you to check the answer. So where does it look like the solution is? The solution looks like it's at the point 3, 2. How do we check? We put 3 in for x and 2 in for y in our equations. If I put 3 in for x and 2 in for y, I end up getting the statement 3 plus 4 equals 7, and that is true. If I put 3 in for x and 2 in for y in the second one, I end up getting the statement 9 minus 4 equals 5, and that is also true. So when they ask you to check an intersection point, that's what they mean. They mean put it in, make sure you get two true statements. We end up getting like 7 equals 7, 5 equals 5. That means that that is the correct solution. So they might just start off by just giving you a graphed system and asking you to check the answer, which is what I'm going to kind of ask you to do right now. So I'm going to ask you, is the point 2, 1 the solution to the system shown below? These two lines, are they going to cross at the point 2, 1? And I'd like you to try to tell me without graphing them. So can you use what we just did a second ago to check whether the point 2, 1 is going to make both equations true, and therefore is it going to be the solution to the system? Is that where those two lines cross? Let's maybe take a minute and a half to pause the video now. Come back after everyone's had a minute and a half to try. You can try in your whiteboards. You can try in the margin of the notes. Unpause it once you had a chance to try. You want to see the answer. Okay, here we go. I need to put 2 in for x and 1 in for y. Let's check. Does 1 equal negative 2 times 2 plus 5? Well, negative 2 times 2 is negative 4, and negative 4 plus 5 is equal to 1. So we get 1 equals 1. So it works for the first one. If I put 2 in for x and 1 in for y in the second one, though, I end up getting that 1 is equal to 8 minus 1, and that is false because 1 doesn't equal 7. So this is not going to be the solution to that system. You'll actually see if I graph these two lines, they do not cross at 2, 1. You'll see that that point is only on one of them. It's on this line right here, but it's not on both of them. The actual solution is the point 1, 3, but 2, 1 is not it. You can check without even graphing it. Now we're going to move on to kind of solving our own, and here are the steps that we use. Step 1 is to solve both equations for y if you need to. If you want to solve, or if you want to graph by finding the x and y intercepts by putting 0 in for x or 0 in for y, then go ahead and do so. I'm going to actually solve for y in all of them, though, just to practice that, because it's a good skill of doing algebra manipulation. Step 2 is then to graph your two equations. Step 3 is to find their intersection point, and then 4 is to check your work. Make sure it actually makes both statements true if it actually is where the lines cross. Step 1, solve both equations for y. Step 2, graph each equation. Step 3, find the intersection. Step 4, check your work. Make sure that that intersection is actually where those two lines cross. Here we go. Here's an example. I want to solve both equations for y so I can graph it. So if I solve for y, I've got not y variable, and not y variable. I need my not y's on the same side. So I add the x over to the other side. I get y equals negative 7 plus x. Here, my slope is 1. My y-intercept b is negative 7. That's where I'll start. This one over here takes a little bit more work. This is really 1x, so I'm going to subtract 1x from each side, because I've got not y, y, and not y. Then these will get rid of each other. I then have 4y equals negative 8 minus 1x. Divide everything by 4. And I'm left with y is equal to negative 2 minus 1/4 x. Here, the slope is negative 1/4. Your y-intercept is negative 2. Then we're going to go graphing them. Hey, there's our equations that we solved for. They wrote it y equals mx plus b, whereas ours was b plus mx. As long as you understand how to pull the information out, the order that those are written does not matter. Now I graph each of them. So graph equation 1, start at negative 7 and go up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. There's the first one. Second one, I start at negative 2 and I go down 1 and write 1, 2, 3, 4, and hey, I've already got the intersection point. You need to make sure you actually answer the question, though. So you need to actually write where they cross. They cross at 4, negative 3. Now we need to check our work. If I put 4 in for x and negative 3 in for y in the equations, it should make both of them true. You can either put them into the original equations, or you can put them into the equations where you solve for y. It doesn't matter as long as you solve for y correctly. If I put negative, so the intersection's right here, 4, negative 3. Now I'm going to check it. Put 4 in for x, negative 3 in for y. Negative 3, does that equal 4 minus 7? Yes, it does. Negative 3 equals negative 3. If I put 4 in for x and negative 3 in for y, negative 4th times 4 minus 2. Well, a fourth of 4 is 1 and it's negative, and negative 1 minus 2 makes negative 3. So it checks out, makes both of them true, which means that the point 4, negative 3 is actually the intersection point. So 4, negative 3 is the answer. Any questions at all, feel free to ask our guest teacher, write it down. You can come in and ask me when I'm next available. Going to give you one chance to try it. So pull out your whiteboard or try it for yourself. You need to graph both of these and then find the intersection point. That's what they mean when they say solve the system. If you're getting stuck on this y-intercept, maybe think about how you can write 3/2 as a decimal. But you need to solve for y to start. So graph the system, find where the two lines cross. Pause the video now, come back after a minute and a half, and you've had a chance to try. Okay, here's what you should have got. Once you solve for y, and recall this one would be y equals 1/2 x plus 3/2 divided, or 3 divided by 2 is 1.5. So this one you'd start at 1.5, and you'd go up 1 and over 2. And then you graph it, and you should find the solution is the point 1, 2 is where they should cross. And that is it for today. Whole goal is to find where two lines cross. So if anything, this was hopefully just a good review of graphing. Solve for y, use y equals mx plus b, find the point of the intersection. So thank you very much and have a good day.